everyone. You ready to get entangled with quantum networking? You're watching Techstrong Gang. Happy Tuesday, everyone. It's Alan Schimmel for Techstrong, and you're watching Techstrong Gang. We've got a good show here with some interesting stuff as this week starts taking off. And we've got some interesting people to discuss it with you. Let me introduce you to our gang for today. First of all, with the fancy background, LLMs, AI, that's what that's a new one I haven't seen before. He's our friend, JP Morgenthal. JP, how are you, man?
I'm doing great. How's everybody today?
Well, we'll find out, won't we? But good to have you. Moving on from JP, we'll go up to, I guess from the background, he's back in Hudson. The man from Hudson. Oh, that was the man from Hope. Well, you're the man from Hudson. Or Uncle. The founder of Tech Field Day, Stephen Foskett. Hey, Stephen, how you doing?
Well, it was nice to be down there in the studio, keeping Bonnie's chair warm, but it's nice to be home. There's no place like home.
Yes, there is. Click your heels when you say that. Click those heels. All right. Welcome, Stephen. And then also home in Harrison, New York, not named for the presidents, our Chief Content Officer, Mike Vizard. Hey, Mike, how are you?
I'll echo Stephen's sentiment. There's no place like home. And any day you're headed home is a good day.
That's right. That's right. Speaking of home, we're home here in our Boca studios, and joining me in studios, our resident Echo Insights analyst and editor, Bonnie Schneider. Hey, Bonnie, how are you?
I'm well. Great to be here, Alan.
Great to have you in the studio. I got to tell you the truth, it's a lot better having you here. I mean, it's not that I have anything against Stephen, but it makes for a better picture.
Well, it's raining.
Honestly, I'd rather have her there too.
Yeah. All right. Let's, it is a rainy day here in Boca Raton, but you can't have sunshine every day.
Wow, it's actually raining in two different places, miles apart in Florida.
Well,
That's not a good sign.
No, but we needed the rain. It's been pretty dry here.
Here too. Yeah.
We need the rain. Anyway, so Mike, Cisco threw their hat into the quantum race, derby, whatever you want to call it. But being Cisco, of course, they're talking about quantum networking.
True that. So yeah, Cisco has revealed that it's working with UC Santa Barbara to build something that feels like a quantum networking entanglement chip. And I guess, in my mind, a lot of us thought about quantum computers as these big kind of mainframe-like things, but maybe they are going to be a little more distributed. And every time I turn around, somebody in China seems to be building a quantum computer that's smaller and feels more like a general purpose machine. So Alan, I know you follow the space, but what's your take on what's going on here?
I think this is the filling out of the ecosystem here, right? But this isn't networking the way you may be thinking of networking. But I just want to mention, hey, we are planning a virtual event on quantum called, of all things, Quantum Leap. And it'll be in October. And we're looking for speakers, sponsors, and if quantum's your thing, you should register for it. I don't think the registration page will be up for another week or two. But I'm looking forward to diving a little deeper into all things quantum there, from quantum to security to quantum chips to quantum networking, algorithms, software, everything else. But, first of all, people have to be familiar with the entanglement principle of quantum, right? Which means you could have two particles or two pieces of matter that are somehow, as crazy as it seems, they could be light years apart even and still connected, entangled, where if one spins, the other spins. One, they copy each other's matter kind of, if one's spinning left, the other's spinning right, whatever it is. So they're intrinsically linked, they're entangled. And once you understand that and you have that and you can manipulate that, well, that allows for all kinds of things. From the craziness of teleportation, Star Trek kind of beam me up, Scotty, to networking perhaps, right? And that's what Cisco's talking about here. Now, the interesting thing, it doesn't necessarily have to be networking like from a router to an endpoint or over the internet. It could just be two quantum chips that are entangled, right? So by using entanglement, you can create sort of a parallel type of processing sequence where you can have multiple quantum chips now working in quantum time, right? Via entanglement. And so if 1,000 qubits is the holy grail or whatever of when we can really hit quantum, picture having 10 100 qubit processors that are networkally entangled and working like that. Yes.
I just I want to address the Cisco announcement with regard to that, right? I think what Cisco is pointing out is that we don't have that kind of scale on the horizon right now. We have, well, no, but what we have is a limited number of qubits chips that are created to create a quantum computer. But the way they're saying that you can scale is by leveraging quantum networking as a way to create multiple quantum computing
Right,
machines.
that's what you're going to have.
in parallel.
You're going
Yeah.
to put them in parallel the same way we did Linux machines into supercomputers, right? It's kind of the same
It-
kind of thing.
I'm interested in how much data can be represented by these entanglements, because the one thing we've always said is that and I've always joked that, ultimately the network owns the cojones for the universal computing, because it's right now the major limitation. You can only get data and so much data to move so fast from point to point, right? So it's your limitation in compute right now is how much data can you move and how far can you move it before you see degradation. So if this thing can carry terabytes of data instantaneously, moving it from point to point, that's a huge game changer. That is a major
Yeah.
game changer.
But the whole idea of quantum networking, I don't know if we could think of it in terms of how much data can I move over a pipe. Because it's particle to particle. So I think the issue then becomes, well, can I do 100,000 particles to 100,000 particle, but each particle has this much on it, but 100,000 of those nevertheless is a lot. JP, honestly, this is hurt your brain stuff, right? That it's kind of so far out there and so radical to what we know and think of. Because I don't think data is necessarily transported. It's kind of an instantaneous, if this knows it, that knows it. You gotta be on some medicinal marijuana or something to kind of get your head wrapped around this.
So for people who are not quantum oriented, think of it like virtual mapped memory. You have your virtual map on top of your physical disk, and your virtual map knows instantaneously whatever's on the disk data, and then you move your virtual windows around to see different parts of the disk, and it becomes just boom, it's available.
So you're saying
right?
the whole universe could be on my thumbnail?
I was thinking more like the cat in Men in Black around the
So, Stephen, it sounds like to me that this is the laws of physics being applied to quantum computing, or is it fundamentally different?
Well, let's I don't know, get down to earth here in a little bit. Put down the wacky tobacco if you can for a second. What Cisco's announcing is pretty interesting, and I'll just point out that we actually heard a very similar thing, a similar story from others at our networking field day. In fact, in March, BT, the big telecommunications giant, presented a whole section or a whole field day session on quantum networking. And Cisco's describing a similar application. The idea is, well, number one, Cisco has some pretty cool technology here. They've got a quantum networking processor entanglement chip. This isn't a quantum processor. This is a quantum enabled networking chip that works at room temperature at very low power and uses the same wavelengths of light that are currently used with optical networking, which is important because otherwise it would not be practical at all. The other thing, like JP was saying, I mean, the interesting thing here is that you can instantly, and when I mean instantly, I don't mean just really quickly, I mean it's there, transmit data in a way that cannot be snooped on, that is completely, synchronous on both sides. And that's a really useful tool for things like public key exchange and encryption, that sort of thing. Another thing Cisco has done is they are using the quantum fluctuations as a random number generator. And I think that those of you in the security space, I'm sure that you all have experienced this and know that random number generators are not very random. And that's a huge problem. And that's one area that hackers, and especially nation state hackers, use to exploit systems. Essentially, they will clone the pseudo random number generator and and generate the same number. Well, it's awful hard to do that in the quantum space, and Cisco has come up with a quantum random number generator. And also, they're working with university researchers to develop future applications that would allow interconnection of quantum systems, but also quantum interconnection of classical systems, which is something that the BT presentation was talking about as well. There's just a lot of really interesting features in here, including some nuts and bolts ones, not some pie in the sky ones. I mean, honestly, a quantum random number generator sounds great.
Well, it's funny you bring that up. Mike, wasn't it just yesterday's show we talked about this issue about some researchers came out with a report that they explaining and being able to anticipate prime numbers, which is, how all of that underlying all of our encryption and the idea of being able to generate random numbers, is this, it's not so random as it turns out, potentially. Anyway, there was just a research report. Whether it was, how true it was, we don't know yet.
But I actually, Stephen raised an interesting point that I hadn't yet considered in the field of intelligence. Think about two computers in two skiffs. Those are compartmentalized rooms, air-gapped, not connected to any network, not even the high side, low side of the government. Actually, air-gapped computers being able to communicate with each other across skiffs. That is an insane intelligence application. You would actually have, because the whole idea of the air-gapped computers, it's not connected to any network, right? It's a standalone computer that performs some type of function, and this would allow those computers to be networked.
Well, but is that a good thing or a bad thing?
Well, from an intelligence application standpoint, it's critical.
Depends on which side of the intelligence equation you are. If you're trying to protect stuff, it's good.
So this comes back to kind of what I'm starting to wonder about here is, so we know that the existing computer architectures we have in place are flawed, and we're using them in ways that are insecure. And to Alan's point, there's prime number issues now that people are figuring out. It feels like all the money being poured into quantum is an effort to kind of reinvent computing, and it might take a decade or so, or is this going to be some, little sidebar esoteric thing that we're using for some vague computer science project? Like, we're going to figure out how to use some chemistry application differently. But, Stephen, how big a deal is this ultimately?
Well, the proof is going to be in the pudding, isn't it? We'll see if they're able to productize this and bring this to market. As a friend of the gang, Bob Sutor, would say, and as he did say in that Techstrong article, there's a lot of uncertainty here in the quantum space.
Yes,
I'm
there's
sorry.
a principle about that, isn't there?
Yeah, exactly. Yeah, the principle says that it's uncertain. And we got to listen to the principle. But no, the point is, we'll see, right? I mean, if Cisco can productize this thing, I can envision a situation where next year, the year after, Cisco brings a quantum-powered random number generator for encryption tasks to market, and that becomes a very important and useful tool. I could also see a situation where they never talk about this again, and we just continue to move on about our lives. So ultimately, it's not research that fixes things; it's products. And
Well,
let's see what products
what
they
about
come
if
out with.
both of those things happening in parallel universes? Back to the wacky tobacco. Just saying. Just saying. But seriously, you know, if we are going, so I'm a Star Trek fan. I have to, if we are going to go on these adventures where no person's gone before, if we're going to continue pushing the boundaries, right? We've spent the last 100+ years exploring basically the theory of relativity and how that affects everything that we do. And it's led to the nuclear, hydrogen bombs, fusion bombs, fission energy, and so many other things. The next breakthroughs that will advance the human condition, we need to understand and harness the power of quantum. And this is one of those times you're happy to be in tech, right? Because we're kind of leading the charge here a little bit and trying to harness this to recreate what we do. And that's kind of what the tech industry does, right? We don't use punch cards anymore. We don't use little floppy disks, right? So we do it because it's hard, not because it's easy, but it's worthwhile. And that's my last word on quantum.
I'm looking forward to the Techstrong Gang being in 2 places at one time. That'll be fun.
Well, we're already
That
in.
happens
Look,
already.
we're in Ohio, 2 places in Florida and New York already. We're quantum.
But theoretically, I could have 2 Stephen Fosketts arguing with each other over a quantum network.
Solar. I'm sorry, I just had to say it.
All right, let's take a break and kind of sober up a bit here. And we'll come back. And Stephen, you can have a report for us on Mobility Field Day, yeah?
I sure will.
Fantastic. You're watching Techstrong Gang.
Well, we are hosting a lot of different field day topics, but as I said last week on the gang, my favorite tech field day, I mean, my favorite child among many is Mobility Field Day. The reason is because, as they were all laughing at me for saying on the gang, they are from another planet. It is always fun to mix and match with people who know something that is completely alien, that are deep experts in a field that you aren't an expert at, because you can really kind of soak in it and learn so much so quickly. Unfortunately, I wasn't at Mobility Field Day. I was in some place called Boca with a distinguished man named Shimmy. But I was checking it out remotely, as anyone can do, watching some of the presentations, and over the weekend, I checked out some of them as well. It's interesting the takeaways that you get from this group when they do come together. One of the things that I predicted going into it was that Wi-Fi 7 was going to be a very important topic. Well, the answer to that is a little more mixed. Wi-Fi 7 sure is important, but some of the key features, especially multi-link operation, are still very much a work in progress. There are standards, but they're sort of pre-standards, and the companies are still working on that technology. Another aspect that we heard quite a lot about was how to bring Wi-Fi to the masses at large public venues. If you've been to a baseball game or a football game and tried to use the Wi-Fi there, it probably works better than the cellular network, but unfortunately, that again is still an area that there's a lot of development happening on. Well, fortunately, because a lot of that development is actually going to be able to leverage some of the features of Wi-Fi 6 and 7 to really broaden access to public Wi-Fi. The other thing that's important is that we're seeing a lot more crossover between Wi-Fi and data center technologies. So things like VXLAN and so on are actually coming into the Wi-Fi space, which again is one of the things that I love about learning about other fields, because you can take ideas from those fields and bring them into yours. The Wi-Fi community was the first to have essentially what we now know of as software-defined networking or software-defined computing, software-defined anything. This idea that you have a controller and then you have basically cattle instead of pets out there as your hardware, and the controller with zero touch will activate and configure and integrate that hardware. Well, that was a very widespread technology on the Wi-Fi side before we ever saw it on networking, let alone on compute. Now it's everywhere on compute, and that has been a really powerful thing. So it's really cool to see some enterprise networking features and ideas like VXLAN come over into the Wi-Fi space as well. So overall, that was sort of the takeaways from Mobility Field Day. I do urge you to check out some of those presentations, especially I just want to give a little shout out here to fellow Futurum analyst Ron Westphal, who talked a lot about some of the intelligence research that we've done internally on the state of mobility, networking, quantum, those sort of things. Check out the Ron presentation. All those posts are up on the Techstrong TV, but they'll also be up on YouTube very soon.
So, Steven, every time I turn around, some telco is trying to get me to essentially ditch Wi-Fi in favor of using LTE as my primary network. And they're pointing out things like, Wi-Fi can get hacked and it's a pain to use. And, to Alan's point last week, I think, you got to stand on one foot to get the connections right. So, is there a case for LTE here, or is Wi-Fi still the dominant player, but Wi-Fi is going to be used in other things?
Well, when all you have is a hammer, everything looks like a nail. And if you're a telco with a big 5G or LTE network, you might start saying, hey, we can do that too. I think there is some crossover, but I think that those that I know who've deployed basically LTE as a broadband backhaul, many of them are happy with it for the price. Many of them are not happy with it for the performance, especially when things get busy. That's not a topic really that the Mobility Field Day folks have talked much about. But again, without casting aspersions at anyone on the call, we found that it's sometimes difficult to implement Wi-Fi in a way that is reliable and high performing and meets the needs of users. And I think that the ease of use of mobile networks has really come a long way, to the point now where, I don't know about you, but I was at a hotel over the weekend. I never connected to the hotel Wi-Fi. I just used my phone on 5G the whole time, and I didn't really suffer for it. So I think that many of us may be starting, I don't know, maybe the bloom is off the rose a little bit on Wi-Fi. Do you find yourselves doing that as well?
Yeah.
Mm-hmm.
Yes. Well, and to the aspersions around Wi-Fi, it helps if people do plug in their Wi-Fi access points, as we found out one was unplugged here. But who knew? But you know what? Real life. So at the HOA where I live, I'm the president of the HOA in Del Boca Vista. But anyway, we're looking at bringing in a broadband provider for the whole development, which is 69 homes. It's not a big development. And they want to bring real fiber to everyone's house, not fiber and then last mile, fiber in everyone's house. And everyone would get 2 Wi-Fi 7, Wi-Fi access points upstairs, downstairs. A whole bunch of other stuff, asynchronous, 500 meg up, 500 meg down. Cable TV, and if you want IP phone, cheap, like $80 a month for all that. I surveyed the neighborhood to see, is this something we want to do? And I was surprised that there were, out of 69 homes, about 8 homes that are on this T-Mobile LTE, You know, if you have a T-Mobile phone, they give it to you for like $30 a month if you're a T-Mobile cell phone customer. They give you a little Wi-Fi access point, and for $30 a month, they get their streaming. They're streaming TV. They don't have cable. They're streaming video. They're using it, for basic connectivity. Now, granted, these are people like all Del Boca Vista people who are probably in their 60s, 70s or greater and are not, I don't think they're uploading any videos or anything they're shooting locally, though one never knows in Florida. Um, but it works for them. It works for them. And so an $80, now they don't have anywhere near 500 megabits up and down, but for what they need it for, it works. And, 30 something dollars to $80, they'd rather keep their 30 something dollar thing. I don't think that works in an office here, maybe with the amount of devices we'd have connected and our bandwidth needs.
I'll
And
tell you one thing. What I do agree with Steven on is like, I believe, and maybe I'm wrong, but I think the LTE connection is more secure than the Wi-Fi connection, especially if I'm like bouncing into some sort of restaurant somewhere and I'm trying to use their Wi-Fi. God knows when the last time that thing was
well,
updated.
Stephen,
Who
my
configured it?
friend Jennifer Jennifer Manila was at your event, wasn't she?
Yeah, and Jennifer is
She is
fantastic.
the authority on Wi-Fi security.
And the truth is, to your point, I don't think there's any intrinsic reason that Wi-Fi is less secure than cellular. In fact, I think that it could be more secure. The problem is that Wi-Fi is generally misconfigured everywhere. I had to reconfigure the local coffee shop's Wi-Fi while sitting there because of they just had the default out of the box configuration from Windstream, and it was just terrible. That sort of thing happens all the time, and I think you're right. Rogue access points and impersonation attacks and all that stuff. It's not as common maybe as people might think, but it does happen, and that can be really bad. I don't know, if you want to be terrified, Google Wi-Fi Pineapple, and you'll learn all about that. On the other hand, there are also rogue LTE cells, Google Stingray, and you'll be terrified as well, and you'll shut off all your phones and throw them in the microwave and be done with it, because all of this stuff, there's all sorts of hacks here.
Yep. Stephen, I wanted to talk about another aspect that was discussed and you mentioned briefly, and that is, stadium level Wi-Fi. So I've been covering that basically with my friends from Extreme Networks now for a few years, and they have a good business around that. I think they're like the official partner of the NFL or something. I know the Cisco Stadium, where the 49ers play in Santa Clara. I don't know if it's still called Cisco Stadium, but with Levi Stadium, yes. They do that. They do a whole bunch of stadiums, and they have made a ton of progress there. And I've seen it when I go to sporting events now. It used to be you can get on the network, but you wouldn't go anywhere. Right? You couldn't get out. But most recently, I've seen absolutely improvements there.
Oh, yeah. Well, it's funny that you mentioned Levi Stadium. Unfortunately, we weren't able to film it because of confidentiality reasons, but we actually had the company responsible for the Wi-Fi at Levi's Stadium lead the Mobility Field Day delegates through Levi's Stadium to show exactly how they implemented that. And it is really well done. That's an example of the good aspect of the Wi-Fi deployments, as opposed to the bad ones that you find mostly everywhere else. Even there, though, we've caught up with those people over time. They've had all sorts of interesting edge case kind of failures that they've had to resolve. And again, happily, that group has come back to us and spoken with us and told us about the lessons learned and the things that they've done to improve access there. It is incredible what happens, for example, when 50,000 people arrive within a half an hour and connect to your Wi-Fi. That's not something that most people experience, but it is something that they've experienced. So I think that it's one of those things where expertise really matters.
You know, when you go in the office in the morning in those big office buildings and you show up around 9 o'clock, you experience the same phenomenon where everybody else logs in at the same time, right?
Well, it's true. It's true. And it's the same when you have like high volume applications. Your Dropbox is synchronizing, your time machine is backing up, your email is downloading. Yeah.
And then you're on the meeting on the 3rd floor, but your office is on the 9th floor, and they didn't route you back to the right connection point. So you're trying to access your access point 6 floors above. Yeah.
He's just making excuses so he could work from home. Come on. Speaking of home, though, an interesting thing that came out of this project I'm doing with my HOA is the average house has more than 30 IP addresses right now. 30 connected devices. You think about it.
Us nerds, well, especially with the IoT space, IoT is causing a rapid proliferation because a lot of these devices are using IP networks now. And that's actually one of the benefits of some of these things, Matter and Thread and Zigbee and Z-Wave and all those things, because they're not on your Wi-Fi network. Yeah, we're seeing a huge proliferation. The other thing is a lot of those IoT devices still use 2.4 gigahertz Wi-Fi, which is increasingly crowded. The noise floor for 2.4 gigahertz is usually 30, 40, even 50%, which means that basically only about half that bandwidth is even available because there are so many devices on that space.
Yeah, on that point, I was configuring a router in the clubhouse of the HOA, and it's a 6E router, and for the first time there were 3 networks. There was the 2.4, the 5, and the 6.
Yep. Yeah, and 6E, that's another benefit of 6E is opening up that 6 gigahertz Wi-Fi because it's, there's a lot less contention, a lot faster too. 6E is great.
If you have a device that can support it.
Yep. Which I have.
There you go. All right. Hey, let's take a break here. We're going to come back, and Bonnie has an Echo Insights report on AI carbon footprints.
Yes.
All right. You're watching Techstrong Gang.
Join CruiseCon Virtual on May 22nd, 2025 for breakthrough strategies to address advanced threat intelligence, proactive incident response, exclusive bonus material, and regulatory adaptation. Hear from our keynote speaker, Admiral Michael S. Rogers, former director of the National Security Agency, and an outstanding lineup of industry experts as they navigate emerging threats, the core principles of crisis management, and the evolution of CISO leadership. Register now for free.
Welcome back to the Techstrong Gang. Well, there's a lot of talk about AI's carbon footprint. So a carbon accounting firm called Greenly, based in Paris, I've actually interviewed them before. They came out with new research, kind of breaking down the carbon footprint of AI, not just the training, which we talk a lot about, but the queries, everyday use. And they had some interesting findings. I took a closer look at their findings and their research in this video. AI's carbon cost doesn't stop at training. Every prompt, every task fuels a growing footprint, and it's accelerating fast. That's the conclusion of a new study from carbon accounting firm Greenly, which shows that emissions accumulate from development to deployment. Building a model like GPT-3 can emit as much carbon dioxide as 112 gas-powered cars do in a year. And that's just the beginning. Envision endless queries, used billions of times. It all adds up. Greenly's research also shows that not all AI tasks are created equal. For example, generating 1,000 images can produce nearly 3 kilograms of carbon dioxide, while the same number of text responses emits just 0.05 kilograms. A staggering 60-fold difference. The gap widens further with added complexity. Supporting additional languages, for instance, typically requires separate rounds of training, compounding the carbon footprint with every expansion. Fortunately, though, the study does point to tangible ways to reduce AI's impact, such as training less often, reusing models, improving hardware and data centers, plus tapping into renewable energy. Combine that with efficient code, and emissions could fall sharply. Reducing AI's carbon footprint isn't about choosing between training and usage. It's about optimizing both. Well, as I mentioned, Greenlee had some suggestions for reducing the carbon footprint of AI use, such as training on 70% use of the model. That was one of the things that they had listed, and many others like leaning into renewable energy, which is something that we've been talking about for a while that all of big tech is doing. But it was an interesting report because it wasn't just from a regular large research firm, but it was from people that are actually doing the carbon accounting for these types of organizations.
Yeah. You know, look, I'm a big believer in reducing carbon footprint, so I don't want this to be taken the wrong way. But I think we'll reduce the carbon footprint when it's economically incentivized to reduce our carbon footprint. So rather than saying, do this to reduce your carbon footprint, we could say, do this to reduce the cost of your compute. I think, at least in today's world, it's a better selling point than it is do it for the right reasons, reduce your carbon footprint.
For regulation in the case of Greenlee, because they're working with a lot of
Right.
European clients.
That's true.
Yeah.
In the EU, yeah.
So at the risk of, confirming that Alan might have been right about something, if you were looking over at Open Compute Project, I think 2 weeks ago now, Google, Microsoft, and AWS, they were all over there talking about ways to build more energy efficient data centers. And they had like whole new approaches where they're pulling out the electrical conduits. There's going to be in a separate cabinet from the compute. They had all kinds of interesting designs that would be essentially more energy efficient. It might take 4 or 5 years to get there in terms of redesigning data centers, but it was interesting that there was a lot of work in this area. So maybe we will get to the point where we are more efficient in the consumption of the energy to drive these AI models. And then the other thing I would just point out is, the folks over at OpenAI were reminding everybody that you should be rude to your AI model and not type thank you all the time because it sucks up energy.
No problem.
That's a good point.
With regard to the video, what I found interesting were a couple of things. One, the comparison of what it takes energy-wise to produce images versus text in the inference side, not even the model side. The other thing I think is really interesting, didn't get pointed out because it wasn't directed to any one particular model provider, was the impact of DeepSeek once again on the industry, right? Because what they recommended, or what Bonnie said was recommended about the reuse of models, I mean, this is DeepSeek 101, right? It's like, that's it. I mean, they actually now can put themselves in yet another camp, which is with a green AI camp, right? Because we did exactly what Greenlee is recommending with regard to how to produce a model and make it available in a economical and also ESG efficient manner, right? So really interesting that it wasn't the place for it to get mentioned, but in another report of similar ilk, you would probably hear DeepSeek getting mentioned again for its innovation.
But isn't that the way of developing markets and developing technology? Is as they develop, you bring in efficiencies?
You would hope. I mean, if there's a reason to, right? I mean, why did automobile manufacturers stop creating, Babe from Supernatural, right? Because where are the muscle cars? The muscle cars are today, right, not ecologically friendly, so to speak, and they become a hobbyist's invention, but not really practical for every day. Now, when did that happen? When we hit peak oil, when the cost of fuel and the cost to manufacture gasoline reached a certain point. It became, and then and there was some support at one time in this country for, not producing a larger carbon footprint. Of course, now we're probably reversing that because, what the heck, billionaires run the planet.
But your analogy is a smart one, I think, because if you look at cars, I'm a car nerd. One of the reasons I think that we've gotten so much more energy efficient as well is because the technology has improved to such an extent. I was looking at a recent, just a mainstream car model that a normal person would buy, It had a 1.3 liter 3-cylinder turbo engine. If I had told young Stephen, young car enthusiast Stephen in high school, that a normal person would buy a 1.3 liter 3-cylinder turbo powered SUV, they would think I was crazy. But the truth is, the technology has gotten so incredibly good that you can deliver 32 miles per gallon from the Buick, whatever it was. And that can be a perfectly satisfactory car from somebody who doesn't know anything or care anything about cars. And I think that that's kind of the analogy for DeepSeek, right? That DeepSeek was able to basically do the same thing with a lot less. And if it's good enough, then nobody cares about having a V8 anymore because it's good enough. But to Alan's point about cost as well, I think one of the challenges, one of the biggest problems with AI right now is that effectively the cost is zero because these things are so incredibly subsidized by people who want to see AI succeed. And so you have these companies raking in VC money and using all that money to build these models and to deploy these systems. And they never, ever have to stop and say, wait a second, we're using how much power? And that costs me how much dollars? They don't care about the dollars. If you've got $1 billion in VC investment, what are you going to do? You're going to fret about a few watts?
But
Why
again,
worry about
this
it?
is the natural way of things. This is the natural way of things. They will start caring. The VCs will start caring. The VCs, I mean, it's the market at work. They'll start rewarding companies that are doing it more efficiently.
Especially when they have those, conflicts with the local power companies and things like that, and that gets into the news, and that's,
Yeah, no,
positive.
look, I've said this before. I remember interviewing the two CEOs of two wildly successful early on NoSQL databases, and I said, does NoSQL stand for no security? He said, we'll have security when our customers demand we have security. AI will become efficient when customers and investors demand it become more efficient.
Well, it actually may be, again, the laws of physics that force them to do so here. There is a cap on how much energy you can actually suck, right? And without nuclear reactors now, as a widely available source of energy, you can. I mean, shoot, if I was Texas, if I were a company, I would not look at going near Texas with my data center, right? Because the last 2 years, winter, they've lost power for how long?
But yet
And-
they're
and not for that.
building, Amanda, our managing editor, says that San Angelo, Texas is on its way to becoming, the data center capital of the world. My younger son's out in Abilene, Texas. They're building huge data center out there. But they're using wind energy
I was going to
because
say they're not on the Texas grid.
well, the biggest, fastest growing energy in Texas is not oil or gas. It's wind and solar, in spite of what the rootin' tootin' cowboys may want to tell you. So,
Which makes perfect sense because it's hot, it's sunny, it's
and
dry,
it's windy
there's
out
plenty
on
of
the
land.
plains. It's wide open. So, I mean, you go out to Abilene, Texas, you see wind turbines as far as the eye could see. And it'll be interesting. And I'm not counting out nuclear either, JP. I think this may be a catalyst to revisit that. And Stephen, we've discussed it on our show before. There's new generations. There's these mini ones, the thorium. There's all different kinds of technologies we could bring to bear here. I don't think the fat lady is sung yet on that one.
Solar is fantastic. It takes up space. That's the only downside to it, is the amount of real estate it requires. But it can generate entire cities worth of
Sure.
energy.
I saw an ad the other day. Someone came out now, I think they were from Korea, transparent solar panels.
Mm.
You could have every building become self-sustaining with that.
I didn't watch the video to find out if it was powering the train or not, but they were putting solar panels in between the tracks on trains.
And and they're putting them above parking lots and in France, above canals and rivers. All sorts of incredible ideas. Yeah, I don't think solar is the end all be all, but I think that it's just such a promising technology. And I agree with you. I mean, I'm gonna shock you, Alan. I do agree that
Wait
nuclear
a
has a
second.
place here.
Wait.
I believe that
Vizard
nuclear
and
has
you
a
both
place.
agree with me in one show?
Wow.
I know. You're not gonna invite me back.
No, I'm wondering if something's going to fall on me or something. All right, must have had a good night's sleep. Anyway, Bonnie, thanks for a great
Sure.
episode on that. As usual, with all of Bonnie's videos, they are at Ecotech Insights, and you can get them
Yes.
on Techstrong.tv.
That's right.
Or our Techstrong TV OTT channel. If you have nothing to do, you want to watch that laying in bed at night, how about it? But I think that's going to call a wrap on today's Techstrong Gang. Thank you for watching. Stephen, thanks for a great report and participating. JP, my friend, always a pleasure seeing you. Hopefully, maybe this week in Orlando. Mike, we'll be in touch. Bonnie, thank you. Thank you. Remember, we've got a full Techstrong TV lineup immediately following this, so stay tuned for that. And as Stephen mentioned, if that Mobility Field Day review wet your whistle, you can go check them out on Techstrong.tv or the OTT app right now. Until tomorrow, this is Alan Schimmel for Techstrong Gang. We're out of here.